everybody. Good morning. I'm glad to be here. My name is Otavio Santana, and today we will talk about frameworks. But one moment, please. Let's share my screen first. So share my screen. One moment. When you are able to see my screen, please tell me. Let me know. But again, thank you to be here. I'm glad to be here. My name is Otavio Santana. And let's talk about what's going on with Java in NoSQL database, especially because right now the trends are going to use NoSQL database more often than you had in the past. Therefore, NoSQL database become even more popular. A little bit about me. My name is Otavio Santana. I'm distinguished engineer at Zup Innovation. Zup Innovation is a company who provides several solutions in technology, especially in the cloud. That's why right now we have uh, 4 open source products to make your life in the cloud easier. We have one to make your application secure, that is ORSEC, where it helps you to use DevSec. Yes, Andreas, the slide will be available afterwards. Charlie CD to continue the integration, continue deployment, Reach to automatize everything as infrastructure as a code. And the last one is Pigo framework, where you can do everything through data, where you can have a single data, a single server, and this information go through multiple devices such as web, iOS, and finally web application in Android as well. That's my job right now, but I love enjoy community. That's why I become Java champion, Java executive member, Apache committer, Eclipse committer, Eclipse project leader. And yes, on my free time, I enjoy to write and read books, especially about cloud and technology. But today is not about me, right? So let's talk about NoSQL database and what's going on with that. Basically, NoSQL database has the same goal that any kind of database. Therefore, you can do the CRUD operation. Thus, create, retrieve, update, and delete information from that engine. And also, yes, have several bugs, have several inconsistencies on the database. However, the main difference is NoSQL does not use SQL as a standard language. Indeed, there is no standard in NoSQL database, at least yet. And to define NoSQL database, right now we define by how the database, the information are stored in the disk, okay? And to make that easier, they create type through that categories. For example, let's go to the first one, that is key value. If you are a Java developer or Python developer, you are probably familiar with map or hash map or probably dictionary, where you are only able to return information from the key. Uh, Here we have several implementation providers of NoSQL database key value type, where I have Redis as a case and React, where React is, I guess, deprecated. There's no update since 2018. The whole engine works as I am only able to return information from the key. Therefore, as you can see here, I have Apollo, Aries, and Aphrodite. Uh, I only able to return sun if I use up the Apollo key, Aries to return war, and Aphrodite to return love and beauty. The main point is I'm not able to, through the sun, find Apollo. That's the first one. Again, key value type. The next one is column family. where I still need to use a row key, where I'm only able to return for information from that key. Yes. Hello, Marcus. I'm glad to see you here as well. I'm only able to return information from that key. Okay. The the main difference here is in the key value, I'm only able to return the whole information as a unique blob. Here, I can split a small piece where I call this small piece as column. For example, here, I have Apollo with sun, okay? However, this time, I put the sun and a small piece of information that we call column, where the column name is dirty and the information, the value is the information itself. Aphrodite has right now two columns instead of a huge blob. Right now, I'm able to return just the color or just the duty instead of always return everything. Aries and Kratos. And another good point, uh, as you can see here, the information is just in time. Therefore, the column family engine will create the column name X when it will need it. For example, here, just Kratos has the column weapon or death gods because it just Kratos needs that. We have a several implementation as well here. As you can see, we have 8 base, Skilla, Cassandra, SimpleDB, Cloudera, and DynamoDB. Where the most famous one for sure is Cassandra. And let's move on to the third type. The third type looks like an XML file or a JSON file, where finally I'm able to return information that's not only from the key. For example, as you can see here, I am able to return information from the name, from dirty, from siblings, and something like that. Again, I have a couple of implementations. I have Apache CouchDB, I have MongoDB, I have Couchbase. Um, I'm able to return to do search through siblings, through name, and not only from the ID. And that's awesome. Besides that, I also have the option to do the sub-documents. What does that mean? Finally, I'm able to put document inside document. As you can see here, I have the siblings document that has one document inside, Apollo, brother of Diana. The 40th one, and the last one that we're gonna cover today is a graph database, where I have several vendors, Neo4j, Infogrid, Sun, Hyper, GraphDB. The main point goal here is basically to do relationship between them. For example, I have 3 entities, Apollo, Ares, and Kratos, where I'm able to do relationship between them. The main difference between graph database and relational database is because graph has an object to hold the whole relationship information. Finally, I have direction of that information as well. For example, here, again, I have Apollo, Ares, and Kratos, where I have Kratos when it goes through Apollo. Kratos killed Apollo. In the opposite side or opposite direction, I have Apollo was killed by Kratos. And that is useful, especially when you think relationship. For example, just because I know Tom Cruise, there's no truth that Tom Cruise knows me. There's something happened with Chris Evans, or any kind of famous actor, singer, and so on. So we need to understand that, and that's really, really useful when you do recommendation engine as well. For example, I watched Iron Man 1, and then I watched Iron Man 2. It has two strong relationships. First is a hero movie, and second, the main actor is golden junior. Therefore, the engine will be recommends to me two solutions, probably Sherlock Holmes and Iron Man 3, okay, or perhaps Avenger, something like that. The whole point is with relationship in a graph database, I can do a lot of relationship, especially when I put directions, and also I can put properties on that relationship as well. Uh, Therefore, if you want to do a huge and complex relationship in the entities, even deeper than SQL, you have this option, graph database. As I mentioned before, those four are only the most popular ones. But right now we have a huge challenge to work with NoSQL database. Especially first, we have over 200 implementation. I talked to you about four. Again, key value, where the most popular one is Redis. Document, where the most popular one is MongoDB. Column family with Cassandra, and Neo4j graph with Neo4j. However, we have more categories. For example, I have multimodal, where is a NoSQL provider who has support to more than one type. For example, DB has support to key value, graph, and document. Thus, it is a multimodal database. We also have time series, and much more categories are coming. On this scenario, we have a huge challenge first to scan the dependencies that we have in Java. And yes, also I'm talking about over 200. It's a huge number, and how can I integrate that with Java? Because it's impossible to use one API to solve the whole everything, right? To make that understandable, I created two categories that has two levels. The first category of Java framework solution, we have the communication level, where it's about how close the API is to the, the database or close to my domain. And another one is about usability, is how much the API is useful to me in terms of I can use to more than one implementation. Okay, communication level, how close my API is close to my database or my domain. Usability, how often I can use the same API, a specific one or agnostic one. Let's move on. Driver. Driver is the communication level where I will be closer to the database itself. I have several advantages when you decide to do that. First, full power of NoSQL database. I use flexibility. For example, if I'm working with MongoDB, I have the dynamic types that where I can insert that. It will look like a map or hash map or stuff like that. My semantics is close to the database itself. Therefore, if I want to work with as uh, data-driven development, I can do that easily. However, as any kind of trade-off, I have the cons. It's too low level of communication. That means I need to do a lot of work. Usually, it's not possible. Usually, the learning curve is high, especially because if I'm using MongoDB and I want to use Cassandra, I need to learn a whole new API. And yes, boilerplate, especially when I need to handle my business with objects. For example, if I have an e-commerce where it has user and product, I need to do the mapper manually if I decide to go to driver. And as much field I have on my entity, as much code I need to put on that. Here you go. We have a sample of driver communication level where I'm using MongoDB. As you can see here, I have 5 lines. So I created the client, then a database, then a collection to finally create a single field. But remember, as much field I have on my entity, I need to put more lines here. For example, in this case, I just have a class with one field, that's name. But imagine right now where I have 10 fields. Therefore, I need to increase more 9 lines. Plus 10, 90 lines, 100 lines. And I need to make sure to test all of that lines. You don't forget any lines. As much code I put on my code on my repository, I need to test, and this might be a bug in some place. Here we have several samples of driver communication level. For example, Neo4j from Java, data stack, Java driver, Redis, the communication with Redis database, that's a key value. Java MongoDB driver, where I'm able to use allow level communication with MongoDB. Let's move on to the next level of communication, object mapper. I have several advantages as any kind of trade-off. I will reduce the boilerplate because, as I mentioned before, as much field I have, uh, as much line I need to put on that. Right now, I don't need to do that anymore. So if I have 10 fields, it doesn't matter. If I have 100 fields, it doesn't matter as well because the conversion will be handled to that object mapper. Right now, I'm close off the domain, and it should be much easier to us. However, there is the impedance between the object and the database structure, and I need to be aware about that. For example, NoSQL database does not provide interface, does not provide ancient, and does not provide polymorphism. There's something that belongs only to objects. I'm not able to extend anything on Cassandra. I do with objects, for example. Here, a sample with Cassandra, data stack mapper. As you can see, I create my try with resource where I assume my connection is closed, my application is closed, it will close everything to us. I created my SQL session, create my mapper, I create my book DAO mapper, and here you go. It will save. It doesn't matter how much field I do on my book. I don't even need to care about that. Okay, I will. How about now? It's better? Okay, I put, yeah, okay, thank you. And as you can see here, I did the interaction on the book. So here's sample. And let's move on to a specific APIs. Communication level, driver object mapper, specific is about usability. The specific has a huge advantage. It has support to specific features, especially in NoSQL. These features matters to us. For example, just Cassandra has support to Cassandra query language. Just Elasticsearch has support to search engine. If I decided to use a specific API, I am able to use that. And usually it's lightweight. However, I have the vendor login, and to new database, I need to learn a new API. Here a sample of a specific database. the stack mapper to Cassandra, Neo4j, object graph mapper, and Morphia. Here is a simple using Morphia communication with MongoDB, where I have my book, where I did my query, and here you go. Again, it doesn't matter how much fields I have on book. However, if I decide to move on to another document type or Cassandra NoSQL database, I need to learn a new API. And the last type that I will talk today of Java solution is about agnostic. It's wonderful because with a single API, I can use and reuse to several NoSQL databases. And that's great. It's much easier to us to enable the polyglot passes. But there's no silver bullet. They overpromise because it's almost impossible with a single API has support to all kind of particular behavior that NoSQL provides to us. And features. Usually agnostic API is a little bit behind if you compare to a specific NoSQL database. And that's normal, right? Because a specific API needs to handle a single NoSQL database. Agnostic needs to handle with several, 10, 20 NoSQL database. Okay, I explained to you about the NoSQL types, the challenge with NoSQL database, why you should move on to NoSQL when you want. But again, there are several solutions that are looking to NoSQL database right now, especially because of the performance and scalability. The how to handle that with Java, the categories about usability and level of communication. The last one here is about platform. What does mean platform to NoSQL database? Platform is a join of frameworks to make easy to use Java with NoSQL database. A platform usually have a dependency injection, a template, a class to make easy to us to communicate between Java and the database itself. Repository, if you are familiar with TDD, and Spring Data is an interface where I don't even need to care. The framework will handle that to us. And the last one is configuration through the 12-factor application, especially because security matters to us, right? So you need to think twice every time when you talk about security. And one way to avoid any kind of code vulnerability is avoid to put user and password directly in the code. And let's move on to, okay, I have a couple platforms here. So Spring, Quarkus, Hibernate OGM, Micronaut, and NoSQL. Let's move on to the first one, that is Hibernate OGM. The main idea of Hibernate OGM is, okay, I already have an amazing JPA annotations and API. Why not use the same API to work with NoSQL, right? It's supposed to be easier to move on between NoSQL database. It has support to JPA PQL. And finally, ONS is Hibernate OGM. It has support to the whole Hibernate family, such as Hibernate Search. Looking to Hibernate as a platform, dependency injection, you can use CDI or EGB. The template code is the JPA annotations and API itself. Once it is JPA, it does not provide repository, and also configuration through the 12-factor application, especially the third one. And as soon we are using annotation, we need to read that metadata somehow. So Hibernate OGM is the user reflection. Here, a sample code of Hibernate OGM. I have my configuration in the persistent.xml, where I have the configuration side that includes the user and password. I have my philosopher NT, where I have my JP annotations, such as NTID, generate value, generate generator, main to one, and so on. Here is an NT to use MongoDB. And the first thing weird, the first C is, okay, MongoDB does not provide relationship. How does Hibernate work to make that possible? When you go to the API sample, it will be even more weird, especially because, as you can see, I have my Socrates NT. I created my NT manager factory, then my NT manager to finally create a transaction. Wait, is Hibernate OGM doing transaction on MongoDB? Does that make sense? I know that from MongoDB 4, MongoDB has support to Java or transaction. However, as the documentation says itself, you should avoid because it costs a lot of power computer consuming. So the good point about Hibernate OGM is, okay, you can use the same API. However, sometimes it does not make sense, especially because fork is fork, knife is knife. When you try to use a fork as a knife, something goes wrong, right? So that's the main idea of Hibernate. So try to use NoSQL as API. The next platform that I would like to cover today is Quarkus. It's a solution provided by Red Hat. It is CDI-like. It has support to active record and repository, so you can have the option to choose between them. Quarkus as platform, so Quarkus has support to Quarkus DI. That looks like CDI, however, it is not, especially because it does not pass as the key of CDI, TCK of CDI. The template, you can use the class or active records. We have support to repository, in this case, Panache Mongo repository. The configuration through microprofile configuration and metadata Quarkus extension. And that means you won't use reflection anymore. You're gonna save the time to warm up your application, and you consume less memory to read that metadata information. Here's a sample of Quarkus NT, the same philosopher one, where I have my extents here, especially because it's active record, and the whole operation is inside the NT itself. So I have my name, I have my codes, and I can do a find my name here. However, if you want to work with repository, you have this option as well. So philosopher repository that implements Panache Mongo repository, and move on. Right now, I have my Aristoteles philosopher NT, where I can do the operation by the NT itself. So I have my NT instance, I persist, I can update and can delete. If you don't like this approach, don't worry. It has support to repository that I mentioned before. So persist, update, delete. Micronaut. So to me, right now, is the most efficient way to use dependency injection on build time. It has support to Micronaut data that looks like Spring data. Micronaut as platform, it has inversion of control, a dependency injection, template Mongo client. To NoSQL database, it does not provide any kind of repository. The configuration through Micronaut configuration, and metadata is through Java annotation processing. Therefore, the whole code is compiling on the build time, the whole code that's including metadata itself. Here's a sample of philosopher where I had name in quotes. And as you can see here, I created my philosopher service and I need to do more boilerplate to do my operation. For example, here I will show the philosopher by the name where I create my filter equals name and then return find all. And finally, I have my save philosopher. The last one that I will cover today is Spring Data. To me, is the more mature one. It has more feature. It's a good one. Spring platform has Spring version of control. To NoSQL, Spring has several templates. I'm only talk about MongoDB to simplify a little bit. However, if you want to use Cassandra, it has support to Cassandra template and so on. So to repository, Spring has a family of repository. So it starts with CRUD repository, goes to paging and sorting repository and Mongo repository, so on. Configuration, it has support, that is Spring configuration, and Spring has support to reflection, and they are working in build time as well. Here's a sample of our code, so document, philosopher, ID, name, code, and so on. My repository, as I mentioned before, Spring has a huge family of repository. So I have my interface here that extend my Mongo repository, and I don't need to do anything else. Here you go, my philosopher, Plateau, Mongo template. I do the basic operation, and if I don't like this approach, I can use my repository. But let's move on. Okay, I talk about the level, about the platforms. So far, the most mature one is Spring, at least to me. Quarkus is coming, and Micronaut is coming because NoSQL is becoming even more popular. But how about standards? There is a huge and amazing article about, okay, the time for NoSQL standard is now. However, it's almost 1 decade ago. Oracle decided to do this kind of approach as well. So in Oracle Java 1 2016, they decided to create an API to NoSQL to, on that time, Java EE, the previous Jakarta EE. Unfortunately, it does not go well and stopped. We have another one. This standard is Apache Tinkerpop. Is a standard to work with graph. Basically, it's a JDBC to graph database where it has a common language, that's Gremlin. And right now, it has support to over 30 graph database. This one is a success case of standards. However, it works only to Apache Tinkerpop. For example, here, this sample that I would like to show. So graph has name and this kind of relationship. We have the Open Cipher, that's an initiative based on Neo4j, inspired by Neo4j itself. The main goal is to be an SQL to graph, no graph query language. So basically a SQL to graph, Neo4j based, and it has 20 graph database and Cipher for Gremlin. Here's sample. If you are familiar with Neo4j, as you can see here, it's pretty similar. And right now we are working in a new specification, Jakarta EE word, that's Jakarta NoSQL. That this one he has a similar approach to Oracle tried to teach, where it has two APIs, one to mapping close to the domain, another one to communication close to the database. Each API has both mapping and communication. Sorry, each type has supports both API and communication. The exception is graph, where it will use Apache Tinkerpop as solution. Therefore, just because we decided to use the standard of Apache Tinkerpop, NoSQL has support to over 30 NoSQL database. NoSQL right now belongs to Jakarta EE, so it's a platform that has CDI as dependency injection. And we were inspired a lot through Spring Data. Therefore, it has support several templates, repository as well. The configuration is going through microprofile config. However, right now the Jakarta config is coming. About metadata, that is reflection and notation processing, where the notation processes is work in progress. NoSQL, the notation is pretty similar to the APA. However, each the notation are common. However, the API is a little bit different. We are using a repository as well. Okay. And as you can see here, we have the NoSQL, Thales Miletus, where I can do several operation sides. So I can use the templates. I can use repository. Again, it's pretty similar to Spring, where I don't have insert and update in the repository interface, especially because it's about repository from DDD. And that's it from my side. So the main goal here is to talk about the difference between NoSQL database and these frameworks on Jakarta on NoSQL database. Right now, at least to me, the most mature one is Spring Data because it has several flavors. It has support to more specific feature. It has more success case. However, more solutions are coming. For example, Quarkus right now has support to MongoDB, Neo4j, and Cassandra. Jakarta NoSQL is coming with support to several databases, mainly because it has support to Apache Tinkerpop, and that is great. And that's it from my side. Is there any question? Okay, if there's no question, thank you all to receive me, and hopefully see you soon. Bye.